Hello, my name's Mark Siebentritt. I'm from Edge Environment, and today we're speaking about a presentation that's been jointly developed with Malcolm Eadie from the CRC for Water Sensitive Cities. And can I first of all thank Hunter and all of the other organisers for the opportunity to be part of this masterclass series. Our focus today is about taking action, and a particular question of where do we intervene and what type of actions are most effective. And to do this, I'll be looking at some case studies from Australia. Australia is like many other parts of the world, and we have cities that experience periods of extreme heat. And it's something that's generally in the psyche of Australians. And every summer, there'll be news articles around the impacts of extreme heat. We also know that extreme heat is going to become even worse in the future. And many of the projections around climate change suggest that by the middle of the century, cities like Sydney, Melbourne, and Adelaide will be experiencing temperatures in excess of 50 degrees. Now, one of the things that's perhaps odd in this context is that while we're highly aware of urban heat, we also know that we're making it worse by the way we build and also redevelop our cities, in which case we're encouraging the development of urban heat islands. Before I go on though, I just really underline how extreme heat and urban heat, it's part of the dialogue and part of the conversation for many Australians, particularly in our cities. And as I mentioned, there wouldn't be a summer that goes by where we don't have significant stories and coverage about the impacts of extreme heat. We've got articles like the ones that are on the screen here, where parts of Sydney are projected at some point, within only a couple of decades, to be too hot to live in. And this is in some of the most rapidly growing parts of Australia. We also find we have studies now where we're really shining a light on what particular types of landscape features are hotter than others. And there's an example here of an article where we've got playgrounds being made of materials that are just really, really hot. Now, as many of you be aware, sport is part of the Australian culture, and so nothing would spark up a conversation like extreme heat and sport. And it's interesting getting prepared for this presentation. Only last week, an article came out, a report came out from the Climate Council. Now, talking about this connection between sport and heat, and the suggestion that within 20 years, soaring temperatures could derail Australian sports. Now, the picture on the screen here is of a person by the name of Pat Cummins, who's the vice captain of the Australian cricket team. Now, I know not everyone listening to the presentation today will be familiar with who Pat Cummins is, but he's an iconic sportsman within Australia. He came out as someone who is commenting and almost supporting this report, recognising how significant an issue extreme heat and climate change will become in the future. So he'd really argued, I think, that there's really quite a high level of awareness about the impact of extreme heat on our communities. One of the things we know now is that the science behind the impacts of urban heat are becoming better. Decision makers and even the community are developing a better understanding of why heat needs to be managed. But one of the challenges still remains is knowing where do we actually intervene and what are the type of actions that are going to be most effective. That's something that's an ongoing debate. And so Australia is really in this interesting point at the moment where we're moving from increased awareness to action on ground. And the case studies I'll present to you today, there are 3 case studies, and we're looking at this issue of how in Australia we're moving from raising awareness through to taking greater action on ground. So let's take a look at the first case study. One of the things that sits behind a lot of the work that's been done around urban heat in Australia is that it started with thermal imaging, or these urban heat maps. Now, these are land surface temperature maps, and the one on the left-hand side here, in fact, all of them are from Adelaide, a western part of Adelaide where we were involved in this data collection. You've got 2-metre thermal resolution on the left-hand side, the left panel, and the middle panel zooming in. And we can see that as we zoom in, we start to get some of these landscape features popping out as being hotter than the rest of the surrounding landscape, with the reds, as you might expect, being hotter areas or areas with high land surface temperature, and then blue being cooler areas. And on the right-hand side, what's interesting is we've got overlaid their data whereby we had national level social vulnerability information overlaid with heat data. And so we can know where do we both have vulnerable members of the community as well as urban heat islands. So this type of mapping really led to an increased awareness right from the general community through to decision makers. And one of the things that it's really spawned is a greater interest in understanding how material selection has an impact on temperature. Now, I've just given you a couple of examples here as part of the slide session today around where we're looking at land surface materials and the temperature impacts. On the left-hand side, where you'll see the car, you've actually got an area of cool seal or a cool road treatment, which is designed to cool down the surface temperature. On the right, we've got a graph there showing examples of some surface temperature monitoring that was done, comparing the average temperature of synthetic turf versus irrigated turf. And I won't go into the details of those results too much here, other than to say we've had this movement from understanding landscape scale land surface temperatures into saying what are the right types of materials that we need to select for our cities into the future. So that was one of the first examples, and we see right around Australia this type of work has been done. The second case study I wanted to focus on was using urban heat data to inform streetscape planning. So this is where, particularly working with the local government sector, we're saying we've raised awareness about the importance of extreme heat, and we recognise that trees in particular can play a really important role in helping to cool our urban landscapes. And so this is an example of some work done in Port Adelaide Enfield Council, and it's a small trial in a suburb called Kilburn. This project here will build up, or this part of the presentation will build up through a series of slides. In the first case here, the work we did was to undertake a tree inventory and look at plantable opportunities. So tree inventory is, as you would expect, it's looking at where are there trees, in this case here, across streets and in some of the backyard areas. But importantly, also identifying plantable opportunities, because we know that while many councils, whether it's in Australia or overseas, they want to increase the size of their urban forest, they need to do that within the limits of the available plantable space. And so what we do to support that sort of decision making is generate these plantable space or plantable opportunities maps. What I want to do is show you a couple of examples how we layer up this information to get to the point where we can have these informed discussions around what to plant where to mitigate heat. So building on this type of information here, we were able to identify on a street segment basis which street segments had the most plantable space and which street segments had the least. So we knew where we could plant more trees. But obviously that's only one part of the puzzle. Next, what we did was to translate that into how many tree planting opportunities there were per 100 metres. Now in doing this, we've got quite a set method or a technique whereby to be able to plant a tree, you must have an area of 5 metres long by at least 1 metre wide. It's quite strict rules around what classifies as a plantable opportunity. What we can also do though is, given we have all that urban heat data, we can start to classify our street segments according to which are the hottest. So you see in the dark red are some of the hottest street segments, and then which are the coolest. And you can see where this is going. We're trying to identify where do we have a large number of plantable opportunities, and also where do we have the greatest issues with urban heat. And where this gets us is to information such as this. So this is really just an example of where we were able to identify the top 100 priority plantable spaces for this case study area. Now we've gone on to do this type of analysis at a whole of council scale, but the idea is to be able to work out if you were committing to planting 500 trees per year, 1,000 trees per year, or even 2,000 or more. You could use this type of analysis to work out where are the highest priority areas to be able to do your tree planting. Now, if we think back through the case studies and this whole trajectory around from awareness raising to action on ground, this is a classic example because work in this area started with awareness raising around urban heat island mapping, and we're now getting to the point where this type of information is being used to inform tree planting programs for future years. So it's a really exciting stage, and it's effectively or essentially using data on urban heat and also red, green, blue or aerial imagery to help identify plantable opportunities, and uses some quite interesting algorithms and neural networks and machine learning processes to do that. So that's our second example of how we're moving from awareness to action on ground. I think the third area is particularly interesting, and it's where we see, especially at a city scale or a council or suburb scale, where a lot of the interest is growing. And I'm going to talk about two examples of landscape planning approaches. The first example is a tool that's been developed by the CRC for water sensitive cities, and it's called the Water Sensitive Cities Scenarios tool. Let me introduce it. What it does is to look at a piece of the urban landscape and it categorises it. It knows where are there areas with buildings and where are there areas of open space. Based on its understanding of the relationship between surface temperature and surface materials, it can then generate a modelled urban heat island map. Once it has that information, it can then generate other statistics. And we can look at air temperature, for example, based on understanding the relationship between land surface temperature and air temperature, but also it can then start to provide insights into Universal Thermal Comfort Index. One of the other nice advantages of this approach is that you can also explore climate change scenarios. So this is an approach which is designed to be able to help inform those type of landscape scale decisions where planners, decision makers and developers are trying to work out what's the best future for their suburb or for a given part of the landscape. Interesting, what sits within this is that whole climate change question or conversation. And what we can see just through a couple of additional pieces of information here, in parts like, or areas like this in Australia, we're seeing a maximum air temperature distribution getting pushed out. And that's something we need to factor in when we're looking at understanding the relationship with climate change. Also, we've got the UTCI distribution, very similar to maximum temperatures, it's getting pushed out. So we need to understand how temperatures and thermal comfort are changing in these landscapes that we're modelling. So this is a tool that is now available for use through the CRC for water sensitive cities. The next tool I wanted to talk about is the Cool Suburbs tool, which has been developed by the Western Sydney region of organising councils. It's also been developed with the support of Resilient Sydney and with the support of the Greater Sydney Commission. It's effectively a rating tool and it has three main components. First of all, there's a large piece of work to review the science, really to review the evidence base for working out where's the most effective interventions or where do we undertake those interventions, and then how to translate those findings into metrics. Secondly, it's got a very extensive stakeholder engagement process, speaking both with people from the public sector and the private sector. And then third is the development of a design support tool or a rating assessment tool. What I want to do is to unpack for you a little bit more how that rating tool is starting to come together. One of the ways it's coming together, and I suppose one of the key principles or frameworks that it's based on, is a resilience approach. And there's a recognition that perhaps some of the approaches to urban heat in the past, they can be a little bit one-dimensional. So for example, if we only focus on planting trees, we're only dealing with one part of the urban heat puzzle, if you like. And so what Western Sydney region of councils, together with Resilient Sydney and the Greater Sydney Commission, have done is to apply this resilience approach. And there are really four key steps as part of it. One is to develop awareness of urban heat. So we want the community to be more aware. The second part is to plan and design to reduce urban heat. And the third element is look at how do we adapt to what's left after we've done those reductions. And then the fourth part is to recognise that in some cases, we can't actually reduce or adapt everything. There is always going to be some element, particularly of extreme heat or those extreme maximums that we're going to need to respond to. And so the Cool Suburb rating tool is based on this resilience-based approach. I wanted to give you a little bit of a window into some of the examples of the criteria or the credits that are coming together for this at the moment. So one area is around urban design credits. So you'll see here that rather than jumping straight into more trees, we're looking at these broader urban design credits. So things like wind paths, wind buffering, and how much at a whole landscape scale, how much green and blue space do we have, and how do we retain existing trees? Interestingly, what you'll see is that when we look at these credits, they start to relate to different parts of that resilience framework. So it really puts an underline or underlines the significance of having this resilience approach. And we can work our way through the credits. So some of the other credits, for example, around cool streets. So how do we encourage shade? or evaporative cooling, or even cool pavements. And you'll see that I gave some examples earlier on of how cool pavements are being tested on ground. There's something that's really gaining a lot of traction in Australia, cool pavements, because there's a recognition that we have a lot of roads, and we know most of our roads are asphalt and they do act as heat sinks. Cool parks and cool park credits are another significant thing. Once again, picking up in very similar elements, but sometimes the opportunities for cooling can be greater in those parks than it can be in a street setting. Cool buildings, there's a whole range of different credits that relate to cool buildings. And interestingly, those credits, they pick up on at least 3 different parts of that resilience framework. So one is on the reduce side, but then also on adapt, with adapt being both in relation to thriving and surviving. Last of all, innovative new technology credit. So we recognise that in addition to all of those other features, we also need to look at how to support and encourage new technologies or even data collection and analytics. So ultimately what the Cool Suburb rating tool will do is it will come up with a series of credits that help to generate a score or a rating, which can be used to either assess new developments, whether it's at a precinct scale or right down to the lot scale. It can assess those and give them a score so that developers or government agencies understand what's more preferred or not. Or, and where we're going to at the moment, because it's still on a prototyping stage, where we hope it will also go to, is that people using the tool can do some what ifs. They can say, well, what if I'm doing a precinct scale development? What are the type of features I would need to include if I'm going to get a high score? So that was the Urban Cooling Rating Tool. So it's another example of a landscape scale planning approach and of the type of thing that I think is going to become even more common in the future. So let me just summarise now. I think what we've seen in Australia is that over the last 5 or 6 years, there's been an increasing prevalence of urban heat mapping, and it's really provided an entry point for awareness raising. I know from my own experience that when you sit down with a group of decision makers or elected members in councils, there are a few things that engage them more than having live a web map version of urban heat information, and the ability to interact with that and to be able to ask questions and look at how heat's being experienced across the landscape. What we also find is that land surface temperature information is starting to inform more on-ground action. And that's going from everything from the type of materials we use in our streets to the use of synthetic turf, even creating the arguments for more trees, right through to informing where do we actually place our trees to get the greatest cooling benefits. But I think perhaps in addition to that, and those things will continue to be important, perhaps the most profound movement at the moment is towards these landscape scale planning approaches. And really what they're aiming to do is integrate those multiple drivers of heat. And they recognise that while greening, for example, is important, that there are many, many other factors that we need to be considering, particularly when we're planning at a precinct scale. We need to be thinking about wind movement, street pattern design, the availability of space that can be developed versus areas that will continue to be in green space, then how do we construct our buildings. So thank you very much, and we'll now move on to the Q&A session.